Coupling and Alignment, API 671. Intro, welcome back to 3D Decode. Today we're going to cover a very important topic in rotating equipment, coupling and alignment as per API 671. Couplings connect the driver, like a motor or turbine, to the driven equipment such as a compressor or pump. Proper selection and alignment are absolutely critical to avoid vibration, bearing wear, and seal failures. Let's break this down. Governing standard. The governing standard here is API 671, which deals with special purpose couplings for petroleum, chemical, and gas industry services. It covers design, materials, balancing, and testing of couplings. Types of couplings. There are three major coupling types used in compressor and pump packages. Flexible metallic disc coupling, the most common in API 617 machines. It transmits torque while accommodating angular, axial, and radial misalignment. These couplings are maintenance-free and require no lubrication. Gear coupling, an older design that can handle higher torque but requires lubrication and more frequent maintenance. Diaphragm coupling, mainly used in high-speed turbo machinery. They offer very low backlash, good flexibility, and high reliability. Alignment philosophy. Alignment is at the heart of coupling performance. Proper alignment ensures long bearing and seal life. On the other hand, misalignment leads to high vibration, coupling wear, shaft bending, and premature failures. API 671 specifies residual misalignment limits after installation. Axial, 0.05 millimeters, 0.002 in. Angular, 0.3 millimeters per 100 millimeters, 0.003 in. Offset, 0.05 meter max. Alignment methods. There are several methods to achieve correct alignment. Straight edge and feeler gauge, a simple rough check. Dial indicator, reverse dial method, gives accurate measurement of parallel and angular misalignment. Laser alignment, the modern standard. It's quick, precise, and generates printouts for documentation. And remember, API requires cold alignment adjustments, which means you must consider thermal growth so shafts align correctly at operating conditions. API 671 Coupling Design Requirements. According to API 671, couplings must be balanced to ISO G1.0 for high-speed operation, transmit rated torque plus 10% overload, be designed for infinite life at operating conditions, be covered with proper coupling guards as required by API 610 and API 617. Mini quiz, quick knowledge check. 1. Which API standard covers couplings in compressors and pumps? 2. What type of coupling is most common in compressor packages? 3. Name one modern alignment method. 4. Why must thermal growth be considered in alignment? Practical task. Here's something you can try. Prepare a coupling alignment checklist that includes the alignment method used, dial or laser, cold alignment offset data, final alignment tolerances, documentation and sign-off. This is exactly what field engineers use during installation and commissioning. Here are some common interview questions with answers. Q. Why are disc couplings preferred in modern compressor packages? A. They are maintenance-free, handle misalignment well, and require no lubrication. Q. How does misalignment affect a compressor? A. It increases vibration, reduces bearing life, causes seal failures, and leads to shaft fatigue. What's the difference between gear and disc couplings? Gear couplings need lubrication and more maintenance, while disc couplings are dry, reliable, and easier to maintain. Q. What is cold alignment? It's alignment done at cold condition with intentional offsets, so when the machine heats up and expands, shafts become properly aligned. Q. Why is laser alignment preferred? A. Because it's quick, highly accurate, and provides documented proof of alignment. Outrow. And that concludes today's topic on coupling and alignment, API 671. If you found this breakdown useful, don't forget to like, share, and subscribe to 3D Decode for more compressor package engineering topics. See you in the next video.